students, very good morning. Today I am going to talk about the partial covalent character in ionic bonds, which is known as Fazan's rule. Okay. So just as all the covalent bonds have some partial ionic character, we know that all covalent bonds have some partial ionic character. The ionic bonds also have some partial covalent character. Okay, this partial covalent character, partial covalent character, this partial covalent character of ionic bonds was discussed by Fazan's in terms of the one rule which is known as Fazan's rule. So this was introduced by a Polish scientist named Kazimierz Fazan. Okay. So first of all, let's see that what partial covalent character means. So when a cation approaches an anion, okay, the electron cloud of the anion is attracted towards the cation and hence gets distorted. This effect is known as polarization. I'll explain it in a better way. Let's first see this, what Fazan's rule actually means. So whenever a cation approaches an anion, the electron cloud of an ion is attracted towards the cation and hence gets polarized. So this effect is called polarization, and the greater is the polarization produced, more is the neutralization of charges, and hence ionic character decreases and covalent character increases. Okay. So let's understand this. So first understand what an ideal ionic bond means and what an ideal covalent bond means. So in an ideal covalent bond, what happens? In an ideal covalent bond, what happens? That the electrons, or you can say there are these two atoms A and B, and the electrons are basically shared, isn't it? The electrons are shared between these two atoms, right? This is what happens here, shared electron pair which is equally distributed. And in ideal ionic bond, what happens? That there is a complete transfer of electrons. There is a complete transfer of electron from the cation to the anion. Complete transfer, okay, of electron. So previously also we studied that there exists some ionic character in covalent bonding, that is there are some covalently bonded molecules which has some partial positive and negative charges which is being developed because of the electronegativity difference. Alright, but here in ionic bond, how come partial covalent character is seen? So let's understand this. Now just suppose we have an ionic compound and it has a cation. Alright, let's understand, or let's rather start this with a new page. Okay, so let's see that we have an ionic compound and it has a cation which is generally smaller in size, and the anion which is larger in size. Alright, and the electron clouds of the anion are, you can say it is like distributed like this. Alright, the anion has electron clouds like this. Now the cation attracts the electron towards itself. Alright, there exists some electrostatic force of attraction. So the cation here, it attracts the electrons from the anion towards itself, and as a result what happens here, you can see the shape is spherical. Okay, and I have not drawn it properly, but it should be spherical. Alright, but here as a result, when it comes close to each other and the positively charged proton, it attracts the electrons. Alright, this shape gets deformed as the electrons come close to the positively charged proton. Alright, and it gets accumulated like this. Alright, so and the shape gets deformed from the spherical shape because of the positive charge of the cation. So this process is known as polarization. This process is known as polarization. Okay, means poles are created now. Alright, and electrons are accumulated more towards this side. Means here what is happening, electrons are being shared. So at first both cations and anions were different, but now when positive charge come close to the negative charges gets polarized and tends to come close towards the positive charge. So it is a kind of a covalent nature where sharing of electron is taking place. So this is now exhibiting covalent character or covalent nature. Alright. So now why in ionic compounds covalent character is seen? It is because of polarization of anion by positive charge. Alright. So here we can clearly see what is happening here. It can only occur in ionic bonds. Alright. Just remember this. So here it depends, this polarization is depending on two factors. Polarization depends on two factors. What is the first factor? First factor is the polarizing power of cation, and the second factor is polarization of anion. These are the two factors which affects polarization. Alright. So the cation polarizes the anion. So how much the polarization is taking place, it depends on the polarizing power of the cation. You can say the strength of the cation. Alright. So Fazan's rule, it states that the covalent character of ionic bond is because of the polarizing power of cation and polarization of anion. Okay. So now let's again understand this in a better way. Let's take a cation. See, the first thing we are talking about cation, and in this what is happening? cation का क्या हो रहा है? cation क्या कर रहा है? पोलराइज कर रहा है. तो cation का हम क्या देखेंगे? पोलराइजिंग पावर. All right. So now this depends on some factors. First is size of the cation. Okay. Size of cation. Now if there are, just say there are 3 cations I am drawing like this. The second one is a bit smaller. This is the second cation, okay, which is a bit smaller in size. 1, 2, 3, 4, 5. Okay, and this is the third one, which is more smaller. So just think about it, that which one can attract the electrons more. Think about it. Obviously the small one. Okay, the small cation, this one, the small cation, the cation which has a much smaller size, because of their high electron density. Okay, because of the density of the protons more here, what happens is it tends to polarize the electron cloud of the anion to a greater extent. Alright. The larger cations, on the other hand, the charge here is distributed uniformly. So it cannot distort the electron cloud much as compared to the smaller ones. Alright. So you can see that if the size of the cation is small size, alright, if the size of the cation is small, the polarizing power is very high of that cation. So as a result, the covalent character will also increase. So hence the compounds containing small cations will have more covalent character. For example, let's see the example. We have lithium Li plus, Na plus, alright, K plus and Rb plus, which is from the first group, lithium, sodium, potassium, rubidium. Alright. So here just see that the size of the lithium is very, very small, right? Then comes the sodium, it adds one more shell is being added. So the size of the cation here, it is somewhat bigger. In Na plus, it is somewhat bigger, one shell is also removed here. Then potassium, it is also a bit large, and in rubidium it is also a bit large. Alright. So Li's lithium, alright, sodium, potassium and rubidium, the cations here, over here, the size goes like this, right? Size is small, lithium has a much smaller size, So the Na plus has a bit bigger size as compared to Li plus. So it is like this, alright, and the covalent character is increases like this. Means lithium, if it is forming lithium chloride, if it is combining with chlorine, it is forming lithium chloride LiCl. So the covalent character of LiCl will be more, alright, then NaCl, then KCl, then RbCl, alright. So LiCl will be more covalent than NaCl and KCl and RbCl because of the smaller size of Li plus ion as compared to Na plus, K plus and Rb plus. Similarly, if we take the next group, that is beryllium, Be2 plus, then we have Mg2 plus, then we have Ca2 plus, and we have Sr, strontium 2 plus. So in this case also beryllium has much smaller size, so the covalent character will increase like this. Okay, so this is what size of the cation does. If the size of the cation is very small, it will have more tendency to distort the electron cloud, alright, and the covalent character increases in that case, means sharing of electron takes place. The first point was that. Let's move on to the second point, that is high charge. The next factor, high charge on cation, high charge on cation. Now, the first factor was size of the cation. Okay, now let's talk about the high charge on the cation. High charge on the cation, which means that we are talking about the period, right? So here what happens is, if the charge on the cation is very high, alright, then it will have again very high polarizing tendency. Its polarizing power increases now because it has more positive charges, and the covalent character will also increase in that case. Alright, see, for example, let's take Na plus, Mg2 plus and Al3 plus. All three cations, they are in the same period. They are in the same period. Alright, they are in the same period. So here size factor will not take place. Now we have to see the strength of positive charges. That means how many positive charges are there. In Na plus there is only one positive charge, in Mg2 plus there are two, and in Al3. So Al3 plus will have greater polarizing power. Okay, it has more power to distort, or you can say they attract the electron cloud towards itself, and as a result the covalent character of that compound increases. Okay, so it goes on like this, Mg2 plus Al3 plus. Alright, here it has more polarizing power, so covalent character also increases. Similarly for the fourth period, alright, this was the third period. Fourth period we have potassium, calcium and so on. So out of K plus and Ca2 plus, which one will have more polarizing power? Obviously Ca2 plus, but because here you can see the number of positive charge is increasing. Okay, so this was the second point. Now moving on to the third point. This is very important. The third point, that is electronic configuration of the cation. Electronic configuration of the cation. This is very important. Now see, in case of two cations, if there are two cations which have the same size and charge, the one with some new pseudo noble gas configuration, a term pseudo noble gas configuration, alright, it means that noble gas JASA configuration means having 18 electrons in its outermost shell. 18 electrons in its outermost shell. Alright, so in case of atoms, or in case of two cations which have same size and charge, the one with pseudo noble gas configuration, that is having 18 electrons in outermost shell, has greater polarizing power, as compared to the other with noble gas configuration, that is 8 electrons in the outermost shell. Now we know that the noble gases, they have this configuration NS2 NP6 means we have neon, so it has 2s2 2p6 configuration. Argon, it has 3s2 3p6 configuration. Then krypton, it has 4s2 4p6 configuration. Here pseudo means having this configuration ns2 np6 nd10 means how many? 10 plus 6 16 plus 2 18 electrons. All right. So the atoms or cations which has this configuration ns2 np6 nd10 configuration, they have greater polarizing power and they tend to form compounds with greater covalent character. Okay. So now the cation which has this configuration ns2 np6 nd10, it has very high polarizing power and the covalent character also increases. Basic example, just see copper. We know the atomic number of copper is 29 and it has this configuration argon 3d10 4s1. We know this is an exceptional configuration, right? It was supposed to be 3d9 4s2, but because fully filled configurations are more stable, so one electron jumps from s to d and so on like that. You have studied all these things. That is why the configuration becomes like this. So now let me write the full configuration: 1s2 2s2 2p6 3s2 3p6 3d10 and 4s1. So just see here students, that if we remove one electron and Cu plus cation is formed, that one electron will be removed from this 4s1, right? So we will be left with this configuration, right? 1s2 2s2 2p6 3s2 3p6 3d10. Now just see that this configuration, is it matching with this pseudo configuration, right? This configuration has this pseudo electronic configuration, right? 10 plus 6 plus 2 18 electrons. So as I said that is why Cu plus ion has very high polarizing power and very high covalent character. All right. So after Cu plus there are some other atoms also, that is Ag plus Au plus, है ना, इसके बाद ही आता है, इसके नीचे आता है. Cu plus का क्या है? 3s2 3p6 नेक्स्ट पीरियड में ना, ये 3d10 कन्फिग्रेशन है इसका. Ag नेक्स्ट पीरियड में है, इसका है 4s2 4p6 4d10 कन्फिग्रेशन. और Au प्लस है 5s2 5p6 5d10 कन्फिग्रेशन, है ना, correct. So all these ions have very high polarizing power and very high covalent character. Similarly, the next element, that is element, that is zinc. After copper we have zinc. Here also the zinc has configuration 1s2 2s2 2p6 3s2 3p6 3d10 4s2, correct. We have this configuration of zinc, and if we remove 2 electrons from zinc, we get Zn2 plus and we get this configuration, that is 1s2 2s2 2p6 3s2 3p6 3d10. Again this is the pseudo configuration. So the cations like Zn2 plus, the next cation is Cd2 plus cadmium and mercury Hg2 plus, they are also having very high covalent character, and because their polarizing power is very high. All right. So this was all about the cation. Let's talk about the anion. Now the anion is getting what? Polarized. So anion का क्या हो रहा है? Polarization हो रहा है. तो ये भी डिपेंड करेगा अनायन के साइज पे कि कैसे पोलराइजेशन होगा. इट डिपेंड्स ऑन द साइज ऑफ द anion. Okay, if the anion is there which has this size, and if the second anion has this size, okay, this size, so the electrons are like this. So larger the anion size of the anion, if the size of the anion is large, greater is its polarizability, means it will get polarized to a greater extent. Why? This is because in case of larger anion, the hold on the electron cloud by the nucleus, it decreases. Okay, because the electrons are now present in furthermore, you can say, shell. Okay, so the hold of the nucleus on this electron is less. So if a cation wants to reach this electron, wants to attract this electron, it will get attracted because the hold on the nucleus is the hold of the nucleus on this electron is less. Okay, so if the size of the cation is big, if the size is large, so it will have the it will get polarized more, and the covalent character in this case will also increase. Alright. Then secondly, अच्छा यहाँ पर एक एग्जाम्पल देते हैं. For example, we have lithium iodide, we have lithium bromide, we have lithium chloride and lithium fluoride. Now let's see, here the cations are all same here, lithium, 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 cations are all same, but see the anion. Here we have iodine, iodide, bromide, chloride and fluoride. Now see what is happening here, that iodide, we know that it goes like this: fluorine, chlorine, bromine, iodine. As we move down the group, what happens? Size increases. As we move down the group, what happens? Size increases. If the size is increasing, this means the anion is also increasing. Alright, the size is more increasing. So in that case, what happens? The lithium chloride has smaller size and iodine has much bigger size. So this is a perfect combination, and that is why lithium iodide will have more covalent character than lithium bromide, then lithium chloride, then lithium fluoride. Alright. After that, the next point will be high charge on anion, high charge on anion. If the charge on the anion is high, it means electrons are more, right? So greater the charge on the anion, alright, easily it will get polarized, and covalent character increases. Alright, it means that if we have an ion which has only one positive charge, and if we have negative charge, I means electron, and some another anion is there where it has 3 electrons. So here electrons are more. If the electrons are more, due to electronic repulsion, it will get polarized easily. Alright, so repulsion also, and if the positive charges come in contact with it, it attracts the electrons toward itself and covalent character increases. Alright, so this is how it gets, like this.